Okay, hello and welcome to the second lecture of the course User Centric Computing for Human Computer Interaction. So, before going into the content of this lecture, first let me recap what we have learned in the last lecture. So, we primarily talked about the basic idea, what this course is all about, and the fundamental concerns, that is the user centric design. Now, we also learned about the briefly about the historical evolution of the field, and in this course, in this lecture today, we will learn the issues and the challenges that are there in this field. This is meant to give you an overview of the things that are important considerations in the field, that are important issues for research in the field, and that are important issues that gives you scope to do further studies in the field. Now, before we talk about the issues, let us first see one definition given by ACM Sikkai about the field, about the area. Now, ACM Sikkai, as you may be knowing, is a body. It stands for Sikkai stands for Special Interest Group on Human Computer Interaction. It is a special interest group of ACM, Association of Computing Machinery, which actually is a premier body in this field and which tried to define the field. So, according to their definition, human computer interaction is a discipline that is concerned with the design, let me underline, the design, the evaluation and the implementation of interactive computing systems for human use and the study of the major phenomena surrounding them. Now, so there are many important concepts, if you may have noticed. So, first of all, we are concerned with the design, evaluation and implementation. So, three things of a specific group of systems called the interactive computing systems, which are meant for human use. So, that is very important, and that is what we are focusing in all the lectures. So, along with these three things, design, evaluation and implementation, the discipline also deals with the study. It is not only design, evaluation and implementation of a field, but also study of major phenomena surrounding these systems. So, both comes under this discipline. Now, based on this definition of HCI by ACM Sikkai community, if we see all the issues that are there, we can broadly divide them into four major issues, or you can say at the same time issues and challenges. First of all, the centrality of human factors, then the nature of the discipline, then the challenge of incorporating humans into the design, and finally the challenge of reducing the design time and effort, design and implementation time and effort through model based design. Let us take them up one by one. The first concern or the issue is the centrality of human factors. As the definition says, the user centric products are meant for human use. So, essentially we need to take into account the human in design of the product, which we have already mentioned in the last lecture. Now, when we say we have to take into account the humans, what we specifically mean? If you may recollect from the previous lecture, we said that the products that we are interested in are supposed to be used by layman users who are not technology experts. Now, why we are emphasizing on this term? Who are they? And why this emphasis on the term layman users or not technology experts is important. Let us try to understand these concerns with an example. Suppose you are trying to book a railway ticket as a traveler. Now, what are the tasks that you are expected to perform to book a ticket? Many tasks actually. First of all, you need to give the name of the stations as input, between which stations you want to travel. Then you probably need to check the availability of trains between those stations and then make a choice which train you want to travel by. Then you have to book tickets, again that requires the checking of ticket availability in that particular train, coach, berth, if you have some preference of course. And finally, you need to make payments. So, these are the things you are supposed to perform to book a ticket for your travel, and you do it with a, or you expect an interface to help you do it. Now consider a DBMS or database manager who is asked to write few queries to retrieve certain information. Now this information may be related to the availability of train between stations, the availability of ticket on a train, the availability of particular berths in a train compartment, so on. Now, are there any difference between what you want to do and what the DBMS database manager wants to do? Technically, both of you are doing the same thing, and that same thing is that there is a railway database. From that database you want certain information, so you are querying the database and you are fetching the information. Based on the information you are performing some action, or you are using the information. But then what is the difference between you as a traveler booking a ticket and for which you need certain information, and a database manager getting the same information in a different way by querying the database directly? Now the difference lies in the needs and expectations of the user. So in your case you expect that there is a quote unquote simple interface which will allow you just to input the station name, or which will display to you in a way you understand the availability of tickets or the trains that are running between those stations, or the availability of berths, and also there is some interface which help you make payments in an easy way. That type of expectations are not there for a database manager. He or she does not need that quote unquote simple interface to get the information. So the moral of the story is, when we are trying to design for somebody, some user, we need to know for whom we are designing, so that we have some idea of the needs and expectations of the user. So we need some user characterization, some user classification. There is a broad classification of user we can make use of. According to this broad classification, any user belongs to one of the three classes: novice, intermittent and expert. Here note that when we are using the term user, we are again emphasizing on the term layman users, who are not technically sound, or at least are not aware of the particular technology behind the system he or she wants to use. Now those users we can divide into three groups: novice, as I said, novice, intermittent and experts. Now novice users are those who are using the system for the first time. Intermittent users are those who use the system very occasionally, not frequently, and expert users are those who knows everything of the system and use the system frequently. But again I want to emphasize that here, by using the term knows the everything about the system, I am referring to the interface, not the technology aspect of the system. As an example, let us consider one design which we are familiar with. So all of you probably have used some word processor system. A popular one is MS Word, which allows you to create documents, write texts. Now you want to save your text. What you will do? In most of the word processors that we use, there are two options provided. Two ways we can do this. One is menu based option. So we go to the file menu, then there is save option, and we use the save option. We click on it and the file gets saved. The other one is what is called hotkey option, a combination of keys. So in case of MS Word or WordPad, we can use Control S, control button plus the S button on your keyboard. So this combination of keys, we usually use the term hotkeys. Now why these two options are given for the same task? Here our task is to save the file, but the way the system is designed, we have two ways to do the same thing. One is using menu, one is using the hotkeys. Why it is so? Again, it is done based on the user classification. So if you are a novice user, you are not likely to be very familiar with the hotkeys, the key combinations, the shortcuts, and you would like to use menus which are designed based on a principle of recognition rather than recall. So, from menu you can actually recognize the actions to be performed and you can do it rather than keeping in mind the particular hotkey combination that are required. But if you are an expert or frequent user, then you will prefer the hotkey combination, as that is the faster option between the two. So, menu based option, although it is easier to perform for a novice user, it takes more time than a hotkey option. So, that is why these two options are kept depending on who the user is. Our next issue is which discipline this area belongs to. Now, as I said, we need to know or incorporate human factors. Now, human factors is a broad term and it requires knowledge and expertise from different areas of study. So, this broad area of user centric design or user centric computing actually is a combination of multiple sub areas, or it is an interdisciplinary field with inputs taken from many disciplines. So, let us see few of those. So, we need psychology, including cognitive psychology. We need a discipline known as human factors. We need expertise in discipline such as design, industrial design, then social science, anthropology, machine learning, artificial intelligence, computational linguistics and computer science. There are many more which are not that prominent as compared to these disciplines. Now, among them, according to SEM SIGCHI, the computer science and engineering is the primary discipline. Others are supporting disciplines. So, if you want to master this area, computer science and engineering is probably the one you should master first, and other you can use knowledge from other disciplines for making the products more user centric. Our third issue is the approach, design approach, which approach we should take. Of course, our approach is to take human into the design. So, we should have a design approach which takes the human into the design. Now, this actually is something we should be very careful about, because when we talk of design, actually it refers to different things to different people depending on who is our target audience. So, for a designer, the term user centric design may refer to design of elements and layouts, particularly the creative design aspects. For an industrial product designer, it may mean something different. It may mean the form factor of the product related to shape, size, look. To an electronics engineer, the term user centric design may indicate completely different things. The electronic engineer may be more concerned about the hardware features, the features at the hardware level, such as more sensors, a reduced chip size, batteries which are more efficient. These are the things that are of primary concern to an electronic engineer. Now, our concern in this course at least is the concern of an application software developer. So, we will basically be focusing on the design of application softwares for interactive systems. And so, when we will refer to user centric design, we will refer to the design of the software for that product. Now, an application software developer needs to follow a development life cycle to build the software, and in this life cycle we have to incorporate the user's needs and expectations. One way to understand this view of the application software developer is to consider layered software designs. For example, the Android software that are very common in the smartphones, we can view it as a layered system. Different layers are designed to perform different activities, as shown in this image. So, at the bottom we have the hardware layer, then we have the kernel layer, the core of the operating system, then runtime and libraries are there in the intermediate layer, and then one framework, and on top of it different applications are running. So, this is one way of viewing the software. And when we are talking of the view of application software, our objective is basically something like this. We need to have a suitable layered architecture that takes into account the user's needs and explicitly. In other words, we need to have a specific layered view of the user centric software. And our final concern is model based design. So, as you know, when we are talking of design of a software, some of you may have done the software engineering course as part of your undergraduate program, and you know that software development is an iterative process. Lots of iterations are there. As an example, just to refresh our knowledge, let us consider the design of a menu based interaction where we have a dozen menu items, 12 menu items. So, how to design this menu? We can have many possible alternative designs. Here we can have 6 possible organizations. One organization can be 2 top level menu options. Under each top level menu option we have 6 sub menus items. Another possible organization can be 2 top level menu items. Under each top level menu item we have, in one case we have 3 sub menu items, in one case we have 4 sub menu items. Yet another organization can be that we have 3 top level menu items. Under one top level item we have 2 sub menu items. Under another second top level item we have 3 sub menu items, and under the third top menu item we have 2 sub menu items. In this way we can have many alternative designs, alternative ways of organizing the menu items. Now, how to choose the right alternative? How to choose which one is best for my purpose? So, typically in software engineering what we do? We basically go through an iterative cycle. So, first we implement our design, then we need to take feedback from users. Based on the feedback, we need to refine our design, then implement the refined design, then again take the feedback, and this loop continues till we are satisfied with the feedback and decide that no further refinements are necessary. Of course, this is a very simplified view of the actual iterative process, which we will be discussing in another lecture later. But the simplified view is sufficient for our present purpose, which is just to show the nature of iteration. So, this cycle continues till we arrive at a final design, and typically this cycle is time consuming, and along with time it needs lots of effort in implementing design, collecting feedback, refinement of the design, and that also involves money. So, you need to employ manpower, that is costly, and the longer the manpower is engaged, the money increases. Now, some elements of this design cycle we can actually automate by what we can call model based design. So, we can have some user models. These models can be utilized for designing the product, at least initial designs, as well as for evaluation without always asking some users to come and evaluate or give feedback. We can employ these models for evaluation. So, now the cycle looks something like this, that we have these models. The model actually can be used for design, as you can see this arrow. Now, there we can make use of guidelines, which is one way of representing a qualitative model of the user. Then these guidelines can be utilized for design, and once this design is done, we go for evaluation. Now, for evaluation we can employ user models, typically those are called computational models of the user. Then based on the evaluation results we refine the design. This of course involves efforts as before, and then the cycle continues, but here the time it takes to complete this cycle is expected to be less because certain aspects are automated. So, the evaluation will take less time compared to the previous cycle, and design refinement is the one which will take time, but overall time will reduce, which entails the reduction in effort and cost. So, this is one approach in user centric design, which is a challenge. On the one hand, we want to reduce the time, effort, cost, but the challenge is how to model the user, how to use the model in the design, whether the models will be sufficient for evaluation, and all these issues. Now, whatever I have discussed today are taken from this book, particularly section 1.4 of chapter 1 of the book. Thank you and goodbye.